Hey everybody, we're going to be talking about confidence intervals for a mean. First, the first important ideas from the text, normal conditions. So the first one being, is the population normal? Second one, is n greater than or equal to 30 by the central limit theorem. And then that third one being the graph of sample data has no strong skew or outliers. Okay, the second part is what our steps. So we talked about this, so we did this a while ago. State, plan, do, and then conclude. And I've got another example to get us through, or to kind of sum up what 7.6 is about. So how tense are the video screens? So a manufacturer of high-resolution video terminals must control the tension of the mesh of fine wires that lie beneath the surface of the viewing screen. Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts. Some variation is inherent in the production process. Here are the tension readings from a random sample of 20 screens from a single day's production. So here are all these, this is all the sample. Here are the summary statistics. So N, remember, is your number. There's our mean, our standard deviation, our min, quartile 1, our median, quartile 3, and our max. Construct and interpret a 90% confidence interval for the mean tension of all the screen productions on this day using the 4-step process. So we want to do that 4-step process: the state, plan, do, and conclude. Okay, so first part, state the parameter you want to estimate and the confidence interval. So our parameter mu is we're testing the true mean tension of all screens produced on this day. Okay, our confidence level. We want to estimate a 90% confidence interval. Okay, so that was our state. The next part is plan. We're so notice in our problem here, they don't say anything about proportions, so that means we're going to be using, they actually say mean, right? So we're going to actually be using a T. So the name of the procedure is a 1 sample T interval for our mean, for mu. Okay, so checking our conditions. Is it random? Well, I know they say random sample of 20. So that works. Is it normal? Okay. The sample is below 30. But when we look at this dot plot, it doesn't show any strong skew or outlier. So, but the dot plot shows no strong skew or outlier. Okay, and if we can go back to this dot plot here. So I'm looking at the dot plot and I see that it looks fairly symmetrical. Okay, so we did our state, we did our plan, and now we need to do our do. So our general formula, this is what we talked about last week. So this is the point estimate plus or minus our margin error. Okay. The formula was it x bar plus or minus t times our standard deviation over the square root of n. That's our specific formula. So we're going to do our work here. So our x bar is 306.32. I get that here from they tell us our mean right here, 306.32. Plus or minus. Now to find our t, we have to go to our table B and get our degrees of freedom. Our degrees of freedom, remember, are n minus 1, so 20 minus 1 is 19. So our degrees of freedom is 19. And then if I go on to that table, I would see that our t would be 1.729. I showed how to find the t on the 7.5 video. So if you need a refresher, go back to that 7.5 video. So I got 1.729. Our standard deviation, they give us our standard deviation, 36.209. 209 over the square root of 20. Okay, so now I'm going to plug all of this into a calculator, and I get 14, or approximately 14 here. Now remember, we want a lower bound and an upper bound, so 306.32 minus 14 is 292.32, and then 306.32 plus 14 is 320.32. Okay, so we did the state, plan, do. Now we have to do our conclude. So what we would say, we are 90% confident that the interval from 292.32 to 320.32 captures, or well, I guess it was captures, sorry. Captures the true mean tension of screens produced on this day. Okay. Now they've got another question to ask about the interval. The manufacturer's goal is to produce screens with an average tension of 300 millivolts based on the interval. Is there convincing evidence that the screens produced this day don't meet the manufacturer's goal? Well, look at our number here. Remember, and our interval is 292.32 and 320.32. So it falls within that interval, right? But they say don't meet. So that means our answer would be no. 300 is within our interval. I hope this helps. Please let me know if you have any other questions.